Okay, guys, for our first lesson for this course is going to be the introduction of integers. But first, let me remind you that in Unit 1, we will not be using a calculator. Also, at any time you need to pause the video while you're taking notes, please do so. There are numerous number systems which can be broken down into subsets, and generally the first subset of numbers that we learn are the counting numbers. So when you were little, you first learned the counting numbers. So that's going to be our very inside subset. So we have the counting numbers. Sometimes these are referred to as the natural numbers. So either term is appropriate. Counting numbers represent items that can actually be counted. So if you're counting your fingers or just counting items, so things that can be counted are counting numbers. So we start with 1, 2, 3, and so forth. Extending the number system is the subset of the whole numbers. So that's going to be our second subset. So the whole numbers. This subset includes the counting numbers 1, 2, 3, plus the number 0. So that's what distinguishes the whole numbers and the counting numbers. Whole numbers are 0, 1, 2, 3, and so forth. The next subset is integers, and integers is what we're going to focus on for this lesson. Integers includes the whole numbers and their additive inverses or their opposites. Integers are negative and positive numbers. On the number line, the whole numbers to the right of 0 are positive. So here we have our origin, the 0. So to the right, we have positive integers. And to the left, we have negative integers. So our third subset are the integers. We have -1, 0, +1, and so forth. So counting numbers, whole numbers are also called integers. Now, once we add in the negatives, the integers include the negatives. Each number has an opposite. Opposite numbers lie equally distant from the origin, which is the number 0. So you can see here is the origin. And if we have -3 and +3, these are opposites of each other. They are equally distant to 0, 3 units away. The opposite of a number is called the additive inverse. So sometimes we will use the term additive inverse, and sometimes we just use the word opposite. They mean the same. A pair of opposites results in the value of 0. So if we have -3 and +3, and we put those together, we are at the value of 0. Now, notice on this number line and in our number systems here, we have counting, whole, and integers. There are no fractions or decimals. So the number like 1/2, -0.75, those numbers are not considered to be integers. So now pause the video, complete this part of the practice, and then continue on with the lesson. Okay, let's take a look at some real-life examples of the use of integers. So if we have a thermometer above 0, we have our positive integers, and below 0 are the negative integers. If we're talking about like elevation, like above sea level. So here is 0 feet, and we can have above sea level, which is a positive integer. But if we are below sea level, we can have a negative integer. Another positive and negative term is if you make a deposit into your banking account, that is a plus. If you withdraw money from your checking account, that is considered a negative. So here are some other phrases for different situations. Gain is positive, a loss is negative, like on the football field, if you gain yardage or lose yardage. If you're in business and you make a profit, that's positive. If you make a loss, it's negative. Again, like we said, above and below sea level. If you earn money or borrow, that's a negative. Ascending, going up, is a positive integer. If you are descending, going down, that would be considered negative. Making a deposit is positive, and a withdrawal is negative. Okay, so pause the video and complete this part of your practice problems. Okay, let's compare integers and let's use the number line. So remember that numbers to the left are smaller than the numbers to the right. So the further left you go, the numbers become less. And when you move right, they become greater. So if we are comparing 3 to 0, so we have 3, we're comparing it to 0. Notice 3 is to the right of 0, so 3 is greater than. So we're going to use the open inequality symbol. 3 is greater than 0, reading from left to right. If we're going to compare -2 and 0, so -2 and 0. -2 is to the left of 0, so it's less than 0. -2 is less than 0. If we're looking at -1 compared to -4, -1 is to the right of -4, therefore -1 is greater than -4. And let's look at -5 and compare it to -1. -5 is to the left of -1, therefore it is less than. Okay, pause the video and complete these practice problems. Now let's talk about absolute value. Absolute value is the distance a number is from 0 on the number line. Since distance is measured with positive numbers, the absolute value of any number is always positive. So when we measure something, we don't say it's -3 feet. Distance is always a positive. And again, the absolute value of a number is simply a distance. So that's why it's always going to be positive. The symbol for absolute value are the two vertical lines where you have some number in the middle. The expressions -5 and 5 both represent the value of 5 because they are 5 units away from 0 on the number line. So let's take a look at this. If I want to know the absolute value of +5, here we are at +5, and we want to know how many units it takes to get back to 0. So the distance from 5 to 0 is 5 units. If I'm at -5 and I'm asked to find the distance that -5 is back to 0, it too is 5 units. So the absolute value of -5 and the absolute value of +5 are both 5 because it's a distance. Absolute value is a distance back to 0. Now let's look at something where we need to be very careful with. These two problems are different than the previous ones. Notice there is a negative on the outside of the absolute value of -5 as well as +5. So the expressions negative, absolute value of -5, and The negative of positive absolute value of 5 is going to be negative 5 because there is a negative sign on the outside of the absolute value symbol. A negative on the outside means the opposite of. When we are working with absolute value symbols, we need to remember the order of operations. Absolute value symbols act as grouping symbols. So you're going to evaluate inside the absolute values first and then apply anything on the outside. So we know that the absolute value, or the distance that negative 5 is back to 0, is 5. But now we are asked to take the opposite sign of that, which becomes negative 5. Again, if we are asked to find the distance that 5 is back to 0, we get 5. But this means take the opposite of that answer, which is going to change this positive into a negative. Okay, pause the video and complete these problems before we come back to the next part of our lesson. Okay, this is the last part. So remember, when you are measuring the distance between two values, one above and one below 0, we're going to take the absolute value of each and then add the values. So if we were asked to find the distance between Mount McKinney, 20,320 feet above sea level, and then the distance at Death Valley, which is 282 feet below, so I'm going to put a negative to represent that, and we are asked to find the distance. So we're going to go from Mount McKinney down to ground zero and then continue down to Death Valley. My statement is going to look like this. So the distance from Mount McKinney to ground zero, and then the distance Death Valley up to ground zero. And then when we add these together, again, we're not going to use a calculator in this unit. This is the distance that Mount McKinley is to Death Valley. Okay, now you finish these practice problems writing your math statement, applying the absolute value. Then it's super important every time that you finish practice problems and you open the answer key, go through each one and make sure you make